So we talked through these two formulas. We're going to go ahead now and look at some application problems of this. So a sum of $1,000 invested at an interest rate of 2% per year. Find the amount in the account after 3 years if the interest is compounded monthly. So we've got our nice formula. It's A of t is equal to P times 1 plus R over N to the N times T power. So let's just plug our numbers in there. We're trying to find the amount in the count. That's A of t there. So we're going to find that. Putting our initial investment there is $1,000. The interest rate there has to be written as a decimal. So got to move the decimal point over there 2 places. So I get 0.02. And then N is the number of times of being compounded per year. And it says monthly. There are 12 months in a year. So my N value there is going to be 12. And my T value up there is how many number of years it's invested. It's invested there for 3 years. So I'm going to put 3 up there for T. So now I can just directly put this all into my calculator here. So let's do that. Let's see if I can bring that over here nicely. You can see the whole thing there. There. So punching our values in there, we get 1,000 parenthesis 1 plus 0.0t2 divided by our N value, and that's the number of times being compounded per year, which is 12. And then caret key. Mine's going to put it up. Some of yours doesn't put it up, and you're going to have to put parentheses around the next 2 numbers here. So putting our values in there, it's 12 times 3. And if yours is not putting it up, you put that in parentheses up there. Otherwise, you're going to get the wrong answer. Your calculator's going to take it to the 12 power and then multiply the answer by 3 when you want it to the 36 power. So we end up getting $1,061.78. So just putting your money in there and only getting 2% per year, you still earned in interest $61.78. So don't put your money inside of a sock and put it in your bedroom drawer or something. You could make interest on your money if you put it inside a account that's going to earn you some interest. There's another formula. It's A of t is equal to P times E to the RT power here. This one here, it's compounded continuously. So what that means is that as soon as your money is inside of an account, it is earning money instantly. It's not like it has to wait for an entire year and then it's compounded the interest at the end of that year and then the money is put into the account. No, as soon as it's continuously, that interest is being put into your account and then interest then can be earned on the interest that you just got. So it doesn't have to wait a period of time. It's just compounded continuously. It's in the account all the time and getting interest on it right away. Banks don't do that because it would give you a lot more money in the long run here. So because what do we got here? We got e to the RT power here. Some of it compounded, find the amount in the account after 3 years. And the interest rate is still at 2%. I forgot about that, at 2% for the interest rate there. So put it in there, 0.02, and then times t here, which is 3. And now we can just simply plug that into the calculator here. We get, 1,000. And then I've got my E, it's right above the ln key, you'll see E. And again, if you don't have, if your calculator doesn't all of a sudden, like mine does, superscript up there, it's putting my I can start to put my exponents up there. If yours doesn't do that, it keeps it down at the same level as the e there is. You're gonna have to put parentheses around this next part. So 0.02 times 3. I don't have to do that because mine's all up there. And I get $1,061.84. Doesn't seem like a whole lot right now, but eventually over a lot of time, if that same amount's in there, the E here is going to, the continuously one is going to get a whole lot more money. So in this case, it's only like 6 cents, but the interest rate's not that much. It's only 2%, which is pretty, it's a little bit more than what we're doing now. Most people are like below 1% right now. And then also the period of time is a really short amount of time. Usually leave things in there a lot longer than 3 years. But over time, the continuously one is going to give you the most. And again, like I'm going to go back up to the other formula there in part A2, the monthly. What that does is at the end of every month, the interest gets put into your account. You don't have to wait until the end of the year and then that interest rate gets compounded at the end of the year. It's compounded monthly and interest is right away into your account at the end of every month. So that's kind of the difference between those. Let's come over here to example 1 here. We're going to evaluate the function at the given value and then round to 3 decimal places. So we have f of x equals 4 to the x plus 1 power there. We're supposed to find f of negative 2. So we can plug our values in there. And 4 to the negative 1 there ends up being 0.25. We can do the same thing here. 4 to the square root of 5 plus 1. So I'm going to do that one. 4 caret key, and again, some of yours, you're going to have to put parentheses around what I'm doing here. And to get it to stop being inside the square root, you have to hit the right arrow here, and then it's plus 1. And you get 88.778. So 3 decimal places, they mean 3 places beyond the decimal point there, so the right of the decimal place point. And then this one says f of e. So now we got to put e in there. This is an interesting one. You go 4 caret key, and you got to plug in e. Remember, e is above the ln there. And then I got to put a first power there because that's what it is. It's the first power. It's asking for a power there. You're going to put that in there. And then there was one other part we had to do there. No, we don't. Oh, yeah, plus 1. So again, make sure the e and the plus 1, they're on the same level. You don't put the 1 up there with the power. We had to do e to the first because that's e to, because it's asking for a power there when I put e in there. They want you to add a power in there. So I get 173.232. Again, 3 decimal places. And then f of negative 1/2. So 4 caret key. And I'm going to do it this way. Negative 1 divided by 2. And then plus 1. And I get 2. So we evaluated those and figured out those results there. Now let's just go ahead and let's graph each of these functions. We got f of x equals 4 to the x. We did some of those earlier on. So if I were to do that, I can go to my y equals here. I'm going to clear these out of here. I get 4 to the x. So let's graph that. So there it is graphed. We can check our table here if we want to see some values in there. And if you got your table here, it's set. It's right above the window key. I can go second window here. If you start your table there at 0 and go by increments of 1, then when you check your table over here, it's just going to give you some nice values then. So, and I can scroll up and down in my table here. So I've got negative 1 and 0.25. 0 and 1, and I've got 4 and 1 and 4. So then I can just simply graph this out. -1 and 0.25, 0 and 1, and 1 and 4. So there's our nice graph. G of x equals 2 to the x. 2 to the x. So again, if you have a hard time plugging your values into that, you can always just check your table there. Got -1/2, 0, 1, and 1, 2. So if I were to graph this out, -1.5, 0 and 1, and 1 and up 2. So again, both of these are exponential growth from the left to the right there. They increase there. And your A value here is 4, and your A value here is 2, which is greater than 1. So therefore, they're exponential growth graphs. I'm going to keep going here. We got find the exponential function f of x equals a to the x, whose graph is shown. This one right here, as we're looking at an example of this one, we've got 0, 1, we got 2, 9 there, and we want to go ahead and write the equation. So we got f of x equals a to the x. So we know we have to write it in terms of some value to the x power there, and we need to be able to find that value. So we've got a nice ordered pair over here. It's 2, 9. So I'm going to plug in 9 over here for f of x, because that's like my y value, and I'm going to plug in 2 here for my x value there, and I get 9 equals a squared, and now I can simply solve for a. So if I solve for a here, I can take the square root, end up getting a equals 3 and -3. But the -3, it's a growth graph there, so a can't be that, it's got to be 3. So we end up getting f of x equals 3 to the x. And we're done. So just taking that nice ordered pair 2, 9 and plugging it into our function there. So we could do the same thing with this one as well. We've got our nice ordered pair there, -1 and 1/2 there. So I can take 1/2, that's my y value or my f of x value, and I'm going to plug in -1 there for x. And then I'm going to undo this equation here. So to undo an equation like this, we got to get rid of this -1 power. Whoops, I just took the square root. So to undo the -1 power there, we're going to take it to another power here, and the power we're going to take it to, we're going to think -1 times what will give me 1 here, because I want to 8 the first. I got to take it to the -1 power. So I have to take this to the -1 power. And so over here on the right hand side, I just get a, because -1 times -1 there, you got a power to power, you multiply those. So when you do that, you think about multiplying by the reciprocal of -1 here, so that you'll end up getting 1 here for this power over here. And so that's how I got that. The reciprocal of -1 ends up being -1. If this was a to the, I don't know, 1/2 here, you take it to the reciprocal of that, so that it would be 2, because those 2 multiplied will give you 1. So over here, I can take 1/2 to the -1, and if you did that, if you didn't know what that value was, we could do that. 0.5 to the -1, and that tells us it's 2. So a there equals 2, so we can set this up. F of x equals 2 to the x. Again, another exponential growth as we go from left to right on the graph there, it's going up. So now you can just go ahead and work on your homework, page 336, 2 to 24, 76, and 80.